Okay, again, ulitin ko para sa mga ano kanina. Kasi naglalag pala. So, continuation siya nung nakaraan, di ba? Meron tayong 2 boxes. And then, yung 5 kilogram, itong 2 boxes, meron tayong 5 kilogram and 10 kilogram. Yung 5 kilogram is placed on top ng 10 kilogram na box. And then, itong si 10 kilogram na mass ay nag-accelerate siya to the right. Yan, katulad dito sa ating figure. Nag-accelerate itong 10 kilogram to the right. And then the upper box is stationary with respect to the lower box. And then we have a static friction coefficient na 0.5 between lower box and upper box. But wala tayo or zero yung ating friction from lower box to the ground. So first is find natin yung acceleration. Yung acceleration ng ating boxes, and then next is yung force ng lower box. So A, find the acceleration. And then B is the force of lower box. Okay, so as I have said kanina, there is no relative motion between upper and lower box. But there is a static friction dito sa dalawa na to. Okay, so wala silang motion, wala silang relative motion, pero merong static force between the upper box and lower box. And then there is no static friction between lower box and the ground. So we are to find the acceleration and the force. So first is apply natin yung law ng first law, yung law of vertical or yung vertical component niya. So wala tayong motion sa ating upper box. Okay, so drawing muna tayo ng vertical lines natin dito sa upper box. Yan, so vertical, then dito. So since walang motion sa ating upper box, so ibig sabihin ng ating force ay mass times gravity lang, di ba? So ang ating N is equal to mass natin ay 5 kg times sa gravity na 9.8. So 5 times 9.8 ilan?
49 po. 49, ma'am.
Okay, 5 times 9.8 ay 49 newtons. Ayan. So, meron tayong 49 newtons. Okay, again, so ang ating box ay nag-accelerate siya on or towards to the right. So, hanapin natin si F at saka yung acceleration or acceleration is equal to A. And then, meron tayong static friction over here, di ba? So, let's say yung friction natin ay small f. Yan. Force natin yung malaking F, friction natin maliit na F. Okay, so tapos na tayo sa vertical component. So next is yung ating horizontal component. So sa horizontal naman, there is no relative motion ng upper box. So upper box has a tendency to rest or inertia, di ba? So relatively, it pulls to the left on the lower box. So walang motion yung ating upper box, pero yung lower box natin ay may motion. Pero at rest yung ating upper box. But due to movement ng ating lower box, may tendency na pwedeng magalaw din tong ating upper box. But due to static friction na pumipigil sa kanya, meron siyang at rest due to law of inertia. So yung static friction natin, it acts na force towards to the right and must exist to keep upper box from moving along with lower box. So yung lower box natin is pulled by force F. Ayan. Ito si force F natin and it's moving at an acceleration A. Ayan. The upper box tends not to move as per Newton's law. All objects like to be static unless acted upon an external force. So our external force here is the force of friction between the upper and lower box. The friction is the responsible for moving upper box towards to the right with some acceleration A. So si friction yung acting force natin dito sa upper box. So now let me draw a free body diagram. So meron tayong box dito na 5 kg, di ba? So 5 kg. And then, yan ang ating applied force. And then meron tayong friction force dito. So friction force natin which is F is equal to and then meron silang common acceleration na A. So ito yung ating free body diagram. So yung mass natin na hinihila ng gravity and since at rest siya, so meron siyang normal force kasi 'di ba at nasa ibabaw siya ng ng lower box. So yung ating lower na ay yung ating force pababa na hinihila siya ng gravity due to mass is na pipigilan ng ating surface dito. So meron siyang acting na force dito sa harapan ay sa taas. Katulad ng diniscuss natin nakaraan, they are netting each other out. So for this one, we will apply the second law. So yung kanina yung first law natin is walang motion sa upper box or yung inertia. And then yung second law natin is forces, di ba? Yung forces, it is the cause of acceleration. Pag may in-apply kang force, tsaka siya gagalaw or mag-accelerate. So yung friction natin, yan, maliit na F, is equal to mass times acceleration or force is equal to mass times acceleration. So since yung force natin dito is yung friction, so friction na ilalagay natin dyan. Friction force. So, in our case, ang friction natin ay 0.5. So, ito yung ating formula. So, 0.5 times 49, ilan?
24.5.
20 ano?
24.5, ma'am.
Okay, 24.5. So, yung friction natin ay 24.5 Newton. Then, meron na tayong given na force. So, pwede na nating makuha yung acceleration. So, let's continue. So, ang ating friction ay 24.5 equal to mass natin na 5 kg, di ba? Force is equal to mass times acceleration. So, force natin ay 24.5 tapos yung mass natin ay 5 times A kasi wala pa tayong acceleration. So, para makuha natin tong si acceleration, divide natin both side by 5. 5, 5. So, ito cancel na. So, A is equal to 24.5 over 5. So, 24.5 divided by 5 ay ilan?
4.9.
4.9.
Okay, 4.9
4.9.
meter per second square. So, ito na po yung ating acceleration. Ayan. So, this proves ng statement na yung friction is actually the cause or it actually helps the motion and acceleration or it causes the acceleration. So, the upper box would have fallen off if walang friction. So, since merong friction sa upper box and lower box, hindi nahulog itong si upper box. So, si upper box, naging still lang siya or dyan lang siya sa ating taas kahit na yung acceleration sa lower box will go high as 4.9 meter per second square. Okay, so next naman is yung sa ating lower box. So, mag-drawing ulit ako ng free body diagram for our lower box. So, ang ating lower box ay 10 kg. And then we have a pulling force. And then, acceleration natin na A. And then, may friction tayo dito, di ba? Friction. Kasi di ba yung, imagine niyo nandito yung upper box. So, pag, kagaya nung nakaraan, di ba, nung tinanong ko kayo, yung pa-right side yung ating, pa-right side yung ating acceleration, may tendency na mahulog yung upper box dahil sa acceleration. So, ito, nag-create siya ng friction dito, pa left side. And then, meron pa rin tayong mass and gravity ng ating upper box. and then mass and gravity ng ating yan. Yan. So, in vertical, there is no motion. Yung total weight is balanced by normal force or normal reaction. Ito yung normal reaction natin, yung N is equal to mg plus mg, yung mass at saka gravity. So, ito yung ating force, di ba, 10 kilogram. So, yung mass natin multiplied by gravity. Pero since nasa surface siya, so nag-net out uli sila. So, meron tayong normal force that keeps the 10 kilogram 10 kilogram box from falling is yung ating normal force from the surface, which is ito. So, meaning, itong part na to, sa ating lower box, lahat ng forces ay balance. Kasi meron siyang left na force, yung sa friction, and then yung force dito ng acceleration, and then yung ating vertical na component. Next naman is sa horizontal. So, yung box natin is being pulled towards to the right by a force F, and the lower box is accelerating with an acceleration equal to A. Ito. So, the force acting on the lower box in the horizontal direction is the force F, and the backward force due to friction. So, this backward force is because the lower box is actually dragging the upper box along with it. 'Di ba? Sabi ko kanina, yung force niya kasi papunta rito, so may tendency na malaglag yung upper box. So, kasi nga nahihila siya. And the upper box therefore exerts a dragging force backward on the lower box. So, we will apply the resultant force, resultant principle. Di ba sa sa resultant principle, di ba meron tayo halimbawa? Yan, 10 kilogram na, yan yung 10 kilogram natin na na box. Ito yung friction, and then ito yung force and acceleration. So, ito, ang ganyang friction natin ay, yan. So, we will let, yung force niya is yung net force na nag-act sa horizontal. So, let F ito yung net force dito sa horizontal. Net force sa horizontal. Again, yung friction natin, ito. Then, ito yung ating force. So, F net, or yung total force, is equal to yung force natin minus sa friction. So, apply natin nila yung second law. So, F net mass times acceleration. Since kasi si lower box ay accelerating siya to the right. So, si F net, we will multiply it by, we will have a mass times acceleration. Parang ano lang, normal na ano lang, physics lang. Yung high school physics. Force is equal to mass times acceleration. So, itong F net natin, di ba, itong F net na yan, is force minus friction. So, F minus F, big F minus small f is equal to mass times acceleration. So, ito, lipat natin sa kabila. Bale, para makuha natin si force. So, F is equal to mass times acceleration plus friction. Kasi ang hinahanap natin ay si force ng itong si force F na yan. So, F is equal to, ang ating mass ay 10 kg, di ba? 10 kg times ang ating acceleration kanina na 4.9 plus yung ating friction kanina na ano yan? 24.5. 24.5. So, F is equal to okay, so calculator ninyo. So, 10 times 4.9 plus 24.5. 24.5 pala.
73.5, ma'am.
Okay, 73.5 Newton.
0.5.
Ayan, so ito na yung ating total force. So, ang acceleration natin kanina ay 4.9 meter per second square. And then, ang ating force ay 73.5 Newton. Okay, next. Okay, ito. An object has a mass of 8 kg. The coefficient of static friction is 0.25. What is the friction if someone pushes the block with a force of 12 Newton? What is the friction if they push with 15 Newton? What happens if they push with a force of 20 Newton? Okay, yan. So, meron daw object na merong mass na 8 kg. And then, meron siyang coefficient static friction na 0.25. Ano daw yung friction kung tutulakin natin siya ng 12 Newton, 15 Newton, and 20 Newton. So, before that, we will need to get the friction force natin. So, ang ating friction force, small f na lang. Small f, yan, friction force. So, kanina nakita na natin yung formula, di ba? So, given na rin naman lahat dito, given yung ating coefficient ng static friction, given din yung mass, 8 kg, and then given na rin yung ating gravity. So, ang gagawin na lang natin is direct multiplication na lang. So, yung ating static friction times sa mass at gravity. So, friction or force friction na natin. So, 0.25. Okay, 0.25 times yung mass natin na 8 kg. And then, ang ating gravity na 9.8. So, ang friction force natin ay 0.25. Ilan nakuha nyo?
$19.6, ma'am.
Okay, 19.6 Newton. So, wag niyo kakalimutan lagi yung yung unit. Okay, yan. So, ito na yung ating static friction. So, friction will increase as you push. So, meron tayong 12 Newton, 15 Newton, and 20 Newton. So, first is yung ating 12 Newton. So, kunwari meron tayong force dito na in-apply na 12 Newton. So, if you push with 12 Newton, meron tayong available friction dito na 19.6 Newton. So, since yung maximum na friction natin ay 19.6 Newton, then it will match the friction which is 12 Newton. So, kung nag-apply tayo ng force natin na 12 Newton dyan, it will match yung 12 Newton. So, ayan. If you push it, since ito yung kanyang maximum na friction. Ay, okay. Okay, so let's continue. Narinig niyo na ako? Narinig niyo ako o hindi? Narinig ako. Okay, sige. May defense kasi dito maya-maya konti. Kaya pumasok si Sir Erwin. Okay, sige. So, yon. Tapos na tayo dito sa 12 Newton na force. So, what if naman kung 15 Newton yung ating in-apply na force? So, ano daw mangyayari? Soburahin na natin to. So, meron tayong 15 Newton. So, if you push it with 15 Newton, the max we can go to is itong friction force pa rin natin na 19.6 Newton. So, if this is our maximum force, then it will only match our 15 Newton na force. So, katulad lang din kanina. So, yung 12 Newton, minatch siya ng 19.6. And then, itong 15 ay minatch lang din. So, 15 Newton pa din ang okay, and then last one is yung 20 newtons. So, what will happen if 20 newtons naman ang ating in-apply na force? So, 20 newtons. So, since ang ating maximum na available na friction force ay 19.6 lang. So, hindi niya kayang i-match itong si 20 newtons. 19.6 newton lang siya. So, yan lang yung ating available friction. So, ngayon, meron na tayong unbalanced na force. So, hindi na siya katulad kanina na balance yung ating force or nagmamatch yung ating forces. So, ngayon, meron tayong unbalanced force. Yan. So, unbalanced.